Hello, welcome to another stream. How about that? How about that? How about that? Hello Yatka, hello Pachnev, hello OG Dump, hello Herzenplots, hello John, hello, Hemiko Epitheater, hello everyone, hello Mustafa, hello Draco, hello Raguil, Zero G Dump, I think I already said hello to you, Lembakote, hello, Serious Sergio, hello, welcome. So today is Tuesday, if I'm not mistaken. I think this time I'm not mistaken, and that means today, according to the schedule, we are supposed to be programming in Rust. So we're supposed to continue developing our TUI framework in Rust that we're developing for another project of ours that we're going to use in the future there. Hello Einari, hello 11 centimeters, hello. So, but since there is advent of code in place, we are dedicate the first half of the stream to solving one of the problems and then continuing with the schedule. Hello Kevin Joberg, I hope I pronounced your name correctly. So yeah, today we're going to be solving the 7th day, I suppose, and the language of today is going to be Go. So yeah, first half of the stream we're going to be programming in Go, and the second half of the stream we're going to be programming in Rust. Absolutely incomparable languages, but people still like to compare them for some reason. But yeah, hello to a step, welcome to the stream. We'll see how it goes. I haven't read anything about the 7th day, but unfortunately somebody spoiled it a little bit for me, and the only thing I know is something about graphs. So yeah, it's kind of difficult to avoid spoilers with advent of code, but I haven't read the description yet. That's the only thing I heard. Like, I heard people are talking about graphs and shit. Hello Okor Kozer, welcome. So let me fetch the latest changes. I think I don't have my latest changes yet, so it's gonna be Brunei origin, and I'm gonna merge everything. So I actually off screen clean up my solutions, like you make them a little bit more presentable, documenting some stuff and so on and so forth. That's why I fetched the latest changes, and that's why you can see me pulling some stuff. Specifically, I decided to, you know, join everyone and start posting my samples, like my inputs as well, because I realized that why people do that. Alright, so let's go to the Advent of Code website and take a look at the 7th day. So yeah, before I start reading, I want to create the 7th folder and just go there. Maybe I'm gonna prepare some boilerplate, for the problem, because we all know that the input is going to be read probably from a file, and also the problem is going to be probably split into two parts, the first part and the second part, and the second part sort of invalidates the solution of the first part. So I wanted to like write a little bit of boilerplate code that will help me to facilitate all of that. So I'm not going to even look into the problem yet, so I'm just going to start my Emacs. Yesterday was a tough puzzle, good luck. I don't know, maybe. If I won't be able to solve it, I will just say that I'm too dumb for this puzzle and I will just move on to programming in Rust. So that's how it's gonna go. So I haven't programmed in Go for quite some time, so I really apologize for any stupid mistakes I'm making here. But the things I remember is that you write hello world like roughly like this, right? So this is roughly a hello world of Go, and I'm pretty sure you can also do something like this if I'm not mistaken. And the way This is not what I wanted. The way you build all of that stuff, you do it by go build, and that's supposed to build the executable, if I'm not mistaken. Stupid fucking mistakes, man. Yeah, exactly. I'm too dumb for this puzzle. By the way, hello, Ceremoon. Hello, hello, welcome to the stream. So, and fucking seriously? Okay, it does make sense. All right, so because the folder is called 07, it decided to call it 07. Is it possible to customize that? Like if I do go build help, does it have, or maybe it's something like help build? And output. Oh yeah, you can literally just provide the output. That's actually great. So it's gonna be O, and I just want to call it main. Let's see if it's gonna go well. Yeah, there we go. That looks great. So, and according to the tradition of Tsoding channel, we're gonna use makefiles to build this stuff. Yes, I'm using makefiles with Go. Deal with that. Cheers. Okay, go. What the fuck? Okay. So it's gonna be main go, and it's gonna be go build O main go. There we go. So, and I should be able to just do make, and it actually repeats quite fast. Look at that. It's a giant level of compilation speed. Look at that. Wait a second. I'm gonna even time it. 100 milliseconds. So it compiles 7 lines of code in 200 milliseconds. That's already faster than Java. Seriously. Trust me, that is faster than Java. So a similar sized program in Java would compile like a second, I think. But yeah, that's... Yeah, not even close to Jai. Yeah. So Jai is actually compiles way faster, and it can compile way more lines in that amount of time. Alrighty. So the way I want to handle stuff this time is by actually parsing command line arguments. So how can I get the command line arguments in Go? Go lang command line args. Go by example. So you do that from the OS package. Okay, sure. It's like Python, right? So in Python you also do that from the OS package. So they were clearly inspired by Python. Go is basically Python, is it not? I think it is. I think it is. So after that, what we can do, we can take args. And I think one of the things we can essentially do is to iterate through all of the arguments. How do you iterate? Like, can you just do something like for file path in one like this? Is it even possible to do something like that? Does anybody know how do you do that in Go? So Go for each Python, but not as bad. Yeah, it's actually a little bit better. Isn't Go inspired by everything? Sure. Alright, so I suppose it's done like that. You essentially use the, walrus separator. I think that's how we do that, and then I'm gonna just print each individual file that we're handling here. It's gonna be print f, and like this, and it's gonna be file path. So we're gonna pass all of the files into the executable, and we're gonna handle them one by one without stopping the execution of the program. So let me rebuild everything. It didn't even compile because why? Used as value isn't how. So you're supposed to do like a range. Is that what you want from me? Apparently that's exactly what it wanted from me, believe it or not. So now if I do something like main, it's not gonna print anything, but if I do something like hello world full bar, okay, it gave me indices. So I suppose I have to do something like this then. Finally. So, okay, and essentially what I'm gonna do here is the following. So I'm gonna have a special target here, inputs, and I'm gonna keep all of my inputs here. So this thing is gonna depend on the inputs, and it's also gonna depend on the main. Right? Then I'm gonna run this on all of the inputs, and it's gonna execute, like try to solve each individual input, so I can just stack more and more different files here and just rerun my program on all of the possible different inputs. Yeah, I think it's going to be very useful because I'm going to have like a sample files, I'm going to have my own input files, maybe some additional files, and so on and so forth. So we're going to have something like solve input, and let's call it solve file, and it's going to be file path. I think this is how we do that, and we're going to just do something like this. Right, I'm going to move it here. So file path, there we go. So right now we don't have anything, so essentially I don't even have to do anything here like that. Yeah, there we go. Okay, so this is going to be my boilerplate, and I'm going to just put my solution here, right? I'm going to pretend that this is my entry point instead of this one, so this solution automatically scales to several files automatically. There we go. Haha, very funny. Hello Belgian, by the way, welcome to the stream. My cat is trying to teach me how to use Emacs, but I'm so bad. You mean cat like a Unix utility? That one? You can use cat instead of Emacs, by the way. So I think we're ready to do that. Let me sip my tea and prepare mentally for the bullshit that I will have to read through. It's not that much bullshit. Like, I'm looking at the shape of the text. It's not that big of a text, so it doesn't contain anything super complicated. So I think it should be all right. We'll see. We'll see. My real cat. She's brutal. Oh, okay. All right. You land at the regional airport in time for your next flight. In fact, it looks like you'll even have time to grab some food. All flights are currently delayed due to issues in luggage processing. Due to recent aviation regulations, many rules you puzzle input are being enforced about bags and their contents. Bags must be color-coded and must contain specific quantities of other color-coded bags. That's fucking brutal, like what the fuck? Bags must be color-coded and must contain specific quantities of other color-coded bags. Apparently nobody responsible for these regulations considered how long they would take to enforce. For example, consider the following rules. Light red bags contain one bright white bag, 2 muted yellow bags. Okay. Dark orange bags contain 3 bright white. Okay, so this is basically the rules. Cool. These rules specify the required contents for 9 bag types. In this example, every faded blue... Okay, every faded blue is empty. Every vibrant plume... The fuck is these names? Vibrant plume contains 11 bags, 5 faded bags and 6 dotted bags, and so on. You have a shiny gold bag. Golden legendary. Is there like a golden legendary bag? That would be actually pretty cool. If you wanted to carry it in at least one other bags, how many different bags would be valid for outermost bag? Okay, you have shiny gold. All right. Shiny gold. Contains 1 dark. All right, so this is some sort of like a tree. That's actually pretty cool. That's actually pretty cool. Maybe it's not necessarily a tree. We'll probably have to. It would be cool to graph with this entire shit. And it also follows the grammar, like plurals and singulars. You also have to parse that appropriately. Maybe we can... It feels like we could try to use regular expressions here, but I'm not 100% sure. I think we could. So essentially what you need to separate here is left and right part. So basically the delimiter in this particular case is going to be contain. You can tokenize each individual line, right? You can tokenize, and then you can split by contain, and you know that the right is the container, and right contains the list of other containers, right? And you can which you can separate by commas, which you can separate by commas. So tokenization could be actually done not only by words, but word and comma. So comma could be its own separate token to actually a little bit easier to split things. Something like that in Haskell would have been actually super cool to solve. But unfortunately we're using Go, so we'll have to suffer. So okay, yeah, and then we can try to graph resolve that. It's actually very easy to parse all that, relatively. The only problem is that I don't remember how to work with strings in Go, so this is something I'll have to Google up. So you have a shiny gold. If you wanted to carry it in at least one other bag, how many different bag colors would be valid for the outermost bag? So you basically have to go up in a hierarchy and calculate how many like sequences of bags you're gonna have. In the above example, the following option would be available to you. So a bright white bag which can hold your shiny bag. Okay, so this is actually true. Yes, it can hold my shiny bag. A muted yellow which can hold your shiny bag directly, plus some other bags. So the other bags don't really matter. You basically need to find the paths to the root. So all of the possible paths from your bag to the root bags, right? That's essentially what you need to do, if I understand correctly. Should be pretty straightforward. You can even try to do that with BFS. You can just start the wave and trace how many times it's split. Okay, so we'll have a lot of problems to solve here. A dark orange bag which contains okay. That makes sense. I really like that. So in this example, the number of bags that can eventually contain at least one shiny bag is 4. How many bag colors can eventually contain at least one shiny bag? So the list of rules is quite long. Make sure you get all of it. The list of rules. It's quite long. Make sure you get all of it. All right. That's cool. So I have a strange feeling that for at least part 1, number doesn't really matter. That's what I feel like. Number doesn't really matter, but maybe it will matter for the part 2. So we're gonna parse it anyway. Okay, so let's maybe introduce some types. So okay, so we need to think how I'm gonna represent all of that. So we need to introduce something like a rule. How did you find the structures in Go? Go struct. I don't remember the specific syntax. Okay, that's the problem. So type rule, right? So this is going to be type rule struct. Brain struct. And what we're going to have here. So we need to have a container, and the container is going to have a specific color. Can I actually like name them like this, because I want to name them with a capital letter, because I like to name types with a capital letter. Can I do something like this? Color string, is that a valid Go type aliases? Yeah, okay, this is literally as opposite to standard type definition. An alias, a standard type definition. So what's that? An alias declaration doesn't. Okay, so whatever, it doesn't matter. So this is the color, and the color is going to be just a string. So container, and on top of that, we're going to have its elements, right? So how to call them? Children? We can call them children. I could do something like this probably, right? So it's going to be sequence of colors, but we also need to store. Okay, so this is alias, and if I define it like that, it will create a completely separate type without that is completely incompatible with string. Do I understand that correctly? Right, it's like a new type in Haskell, right? So this is a new type, and this is like a type alias. Right, thank you, Limbakoto. That makes sense. That's actually very useful. That's actually pretty cool. So, do we have tuples in Go? I'm pretty sure we don't, because otherwise we wouldn't have like multiple return stuff. So we'll have to introduce like another struct, right, that contains the color and the amount of integers, and I need to call it somehow, right? So how can I even call it? That's a good question. Is there any good name? Right, so it could be color plus amount. How would you call it? So if this is a rule, well, if this is children, this could be a child, right? So this could be a child. So another thing here is that we need to introduce a function that parses line to a particular rule, right? So, and it returns a rule. I suppose we don't have to do semicolons here, right? So something like that, something like that. And the easiest way to go about that would be to go about that, get it? Go about that. Line to rule, and I'm gonna provide just a single example here, trying to parse all of that. Right, so this is essentially what we're trying to parse, and then I want to simply print ln all of this. But can I return an empty rule? Is that a thing I can do? I think I should be able to do it like that. And then we can do something like fmt print f. And how do I print like a structure? Is it something like s? Can I just do s? Is that a thing I can do? Let's find out. Let's find out. Imported OS, but not used. Thank you very much. Okay, I think it works. I think it works. And if I, for example, construct something with this rule, so it's something like color. How do you construct structures in Go? It's a name, so this one is a color. Something like your mom. Right, and everything else is gonna be the same. Do you expect this thing? A known field. Oh yeah, a container. Container your mom. There we go. Yeah, there we go. So we have your mom, and then the rest of this thing. So it's a single rule, and with the children, you can have something like a child. I'm not sure if it's a correct thing. Maybe I have to use like a square brackets. I haven't programmed in Go for quite some time, so I really apologize if I'm doing something very fucking dumb. Yeah. So this is gonna be color. Got him. And the amount is gonna be 69, of course. So let's see if it's gonna fail. Okay. I suppose expected new line. Something. All right, so maybe that's what it wants. I think this is something like this. Do I have to do something like this? I think. There we go. Okay. Cool. I really like that. So at least I can then inspect the rules. Inspect. So once I parse them, I can inspect them and make sure that I parse them correctly. You know what I like about Go is that it has a consistent syntax, right? So you have generic types, and the parameter of a generic type usually goes after the type. And that's why I can always be sure that this is how I, describe an array. And another consistency is that if you want to initialize some compose type, you first have to type the type of this type, then curly brace, and then initialize it here. I like the consistency because you can sort of guess how to do certain things. So this is what I mean when I talk about ergonomics of the language. The ergonomics of this language is actually pretty good. It's consistent. So you learned how the syntacticals work in one place, and you can be sure that they work in a similar way in a different place. So that's cool. I really like that. Okay, guys. So how can we, what we can do now? If I try to split things by words, for example, right? If I can split them by words, what's gonna happen? Go split string. How can we split the strings? So Housekick isn't consistent, or what's with the talk about consistency? Where did I say that Housekick is inconsistent? Jesus fucking Christ, what is going on in your head? Okay, split. So this is how we split all of that, and that gives us the array of the. Oh, this is actually pretty cool. I like that. So okay, so I'm gonna take the light and split this thing like this. So it accepts. It's supposed to be a method, right? Is it a method? It is a method, but it's a method of strings. Okay, so I'll have to import strings like this then. Okay. I'm thinking what language then isn't. Well, all of the languages are consistent or inconsistent to some degree. It's not like a binary division. It's sort of like a spectrum, right? So the level of consistency. So the level of syntactical and semantical consistency in Go is good. In some languages, it's not as good. It's not like a discrete thing. It's a continuous thing. So you're thinking about it incorrectly. Is music louder than before? No, I don't see the music being louder than before. So if the music is loud, please tell me. Inside struct, array structs, and first, so we can simply use. Okay, cool. I already moved on to a different thing, but thank you for mentioning that. Okay, so we're gonna have strings. All right, so it's gonna be strings. And I think maybe we don't even need to tokenize this shite. I think it's gonna be okay. So I'm gonna do line, and I'm gonna split contains. Like we're literally gonna split it by word contains. And let's just try to print that. Print ln. Oh, and I think I'm okay with not doing anything here. So what I'm thinking is that I'm going to let me take this sample. Let me take the sample and save that sample here. Music is okay now. Thank you so much. I really appreciate that. So okay, whatever. Right, let's see how it's gonna work now. Okay, so this is what we managed to separate so far, right? Contain, right? So because it's a single contain. There we go. So light red bags, right? And this is a separation. It's kind of Pepega. Like it printed it in a very Pepega way because I don't see a separation between like strings. They could have at least properly separated it or something, but okay. Try. Okay, so let's give it a try like this. Is that what I have to do? Oh shit! Thank you so much. This is exactly what I wanted. This is like literally what I wanted. Thank you everyone who mentioned that. Okay, is there any way to map slices? Golang map slice with single slice values. No, map is a associative array, but I want to actually map it. So there's no map operation. You literally have to just for loop it, right? Yeah, I think so. I think you have to go maps in action. Okay, so I mean that's totally fine. I'm totally okay with that. So, but it would be a little bit easier if I didn't have to do that. All right. So what is that? Is it a var? I need to come up with the name with this edge thingy, right? I can just call it A, right? So this is the first separation, like a top level container separation, and then I want to extract like A. So, and what I can do here now is I can try to split strings split bags and see what's going to happen here. So you will see what's going to happen. And then I'm going to try to do fmt printf like this, right? So this is what we're doing here. And let's see. And can it use... Oh yeah, this is because it's not A, it's A0. There we go. So, and this is how I separated it. So this is how I essentially extracted the color of the container. So is there any way to trim everything? How do you trim? Trim. Oh, this is how we literally trim it. Cut set. A slice. Okay, show me example. Okay, we can provide spaces there then, and then I can take the zeros one and then strings trim trim, and I'm gonna provide the spaces. Okay, so did I extract? There we go. I extracted the light red. The light red out of the light red bags contain one. Blah blah blah. Right. Trim right. But does it? How is that different? It also accepts cut sets, so it's not that important in my opinion. Right. Whatever. But we can use trim right. Maybe it's gonna be a little bit faster. Maybe it's gonna be a little bit faster. So, and this is essentially our container, right? So we're gonna have a var container. There we go. Then we're gonna start working on the other things. So this time we'll have to take this thing, but this one is gonna be 1. And we're gonna split it by comma. Right, we're gonna split it by comma. So we're now trying to parse the right part. Right. So, and this is what we managed to separate here. Right. You see, this is what we managed to separate here by commas. This is what we managed to separate here. So for this kind of things, maybe it would be easier to use regular expression at this point, right? Just use regular expression. We'll see how it goes. Oh, by the way, I can just do container and container. Is there something in Go that if the field and the variable are called the same thing, I can just omit that? Is that a thing I can do? Like in Rust? Is it possible? That would be great. Can I do something like that? I think I cannot. Oh, it's actually... Oh, yeah, so I just need a comma here. Too few in a rule literal. So if I'm gonna do something like that, I will have to... Okay, I see. So yeah, it's complicated. Right? The answer is it's complicated. I still don't know how to call this A. I really wish I had like a proper name for it, but I just don't have it. Yes. Alright, so how do I do regular expressions in Go? Go regular expressions. Rejects. I hope I don't have to, you know, install anything like a separate thingy here. For regular expressions. Is that a separate package? So go by example. Alright, I'm gonna just try to import it and see if it's gonna work or not. Useless Pony, welcome. Welcome to the stream. Haven't seen you well. How are you doing? How are you doing? Hope you're doing well. Okay, so it couldn't import... oh, it's imported but not used. Okay, that's cool, that's cool. At least I didn't complain. If I try to import something that doesn't exist, it will tell me just right away it doesn't exist, but if it exists, then not used, but... Okay, that makes sense. So Go and Rust, not the circle drag. Oh, by the way, how my approach will react to contain no other bags, right? So no other bags. So this one is very interesting. So if I'm gonna put it somewhere here, let me comment it out. And let me take this example. Let me take this example. I kind of like this problem, not gonna lie, for some reason. I don't know why. All right. So yeah, so the second thing here is no other bags. And one of the things I can do essentially is just check that the string, the A1, is going to be equal to that. Let me double check this thing. Yeah, no other bags. If A1 not equal no other bags, then we're gonna try to parse the bags, right? Then we're gonna try to split them into their elements. So, and how we're gonna do that? I think I'm gonna do that. So strings split. And the delimiter is that. All right. Regular expression. So first we'll have to compile a regular expression. Let me grab one of these things, I suppose, since all of that is going to be split anyway. So this is what we expect here. We expect a number here, 0, 9 plus. Then we expect some bullshit here, right? I might say like anything here, and then bag and optional s. So this is essentially our regular expression, right? Hopefully, I think that's what it is. Okay. So let me put it here. And how do I compile them? I think it's oh, you can literally do it like that. All right. So you can do rejectsp. Of course, you have to do something like this. Rejectsp match string. And what string we're matching? We're matching one of those strings, though, right? We're matching one of those. So what we have to do is for child range for these things. And this is a child. And that thing should give us a bunch of matches, right? So this is going to be a match. So it also may return some additional stuff that we don't care, but there we go. And after that, I want to just print this entire thing. Print this entire thing. So we'll see how it goes. It's going to be something like this. Match, and there we go. So if it's not equal to that, it's not going to print anything. We might as well actually print something like this. Print ln child children bags, right? In that case, no bags were found. no bags were found. Otherwise, we're gonna print them all. Gotta print them all. Okay. Type string. Excuse me. So this thing is supposed to be. Cannot use child type int. Ah, I forget that it's a go. All right. So no bags were found. So children bag, no bags were found because we are parsing this. Faded blue bags contain no other bags. It's essentially that. So, but if we do something like this, true. The fuck is this? We have to print them with new line. Yeah. So we found at least 2 of them, but where are their values? What the fuck? So what's the second value though? So there's a match. I need to do capture groups. I think I need to do capture groups. To go rejects capture groups. A true bag, I see, yeah. Functionality and go regular expression. Don't tell me it doesn't support that. Don't tell me it doesn't support that. I won't accept that. You must compile. Okay, so you must compile this thing. Find string. Is that how I do that? So there is also the second argument. What's the second argument here? Is that an error of some sort? So is that an error? I want a quick way to get the capture groups without, you know, bullshit. Okay, it's an error. I want a quick way to get the capture groups because so match returns true. Okay, I think I have to do that. Alright, so let's compile this thing first then. Oh my god, why do I have to compile? Why can't you just return me the list of matches when I match the string? Like why do you force me to do this kind of bullshit, bruh? Like why? It's not that hard, like, to design a good API that just lets me do what I want very quickly. So find substring submatch. Okay, so that's what I have to do here now. Find substring submatch. Right, so it gives me what? It gives me something. Let's do fmt printf. Okay, child declaration not used. This is because I should use child. And give me... Okay, this is what I'm talking about! This is what I'm fucking talking about, yes. Why can't we just have that as a single function? Maybe we do have it as a single function. Let me find it. Like, why do I have to compile first? Whatever, I mean, it works. So, it works. And that's cool. So it extracts the amount and it extracts the color, and now we can just, you know, work with all of that. Child's not used. Okay. So this is a container, and we're also gonna have children here. So, and children are child like this. Is this how I do that? Oh yeah, this is how I do that. There we go. So, and how do I append them? Oh, by the way, golang string to int. How do I convert this to integer? Strconf. It's a strconf. Cool. Let's import that shite. Let's import that shite, bruh. Strconf. So submatch. So this one is going to be something like B, I suppose. Right. So this is going to be something like B. Compile it in a loop. Oh yeah. That's cool. Thank you so much. So in this particular case, we don't have to do that. Vason subscribed with Twitch Prime. Thank you. Thank you so much for your subscription, your first subscription, by the way, and welcome to our epic Go Club. So now you even have a Go emote. How about that for epic Go enthusiasts like you? All right. So, and let's do children. Children. There we go. So, and in here, I'm not really sure, like, if I do this thing correctly, var, and maybe I have to replace them with like the walrus operator or whatever. I don't really know how to program Go, I'm sorry. So, the thing I want to do, children, I think it's append, and I need to create a child right on the stream, MongoTOS. So the first thing is amount, amount b1, and we use strconf a to I, there we go, and then the color is gonna be b2, there we go. So this is how we're gonna go about it. I think it's gonna compile now. I think it's probably gonna compile that. We'll see. I think append doesn't work like that. I think you have to do it like this, right? So, if I remember correctly. Is this how you do that? Okay. Multi-value of... Oh, for fuck's sake. Okay. God fucking damn it. Are you fucking serious? Are you... God fucking damn it. You know what? I don't care. I'm gonna just ignore it. Fuck that. Would you look at that? So this was the original line. Light red. Oh, let me actually print it properly with all of this bullshit, you know. Look at that. So the original line was light red bags contain one bright white bag and yellow bags. So the container is light red, and we have a bunch of children, and each child is bright white, right? And amount is one, like, yeah, bright white and amount is 1, and then muted yellow and amount is 2, and everything is parsed properly, as you can see. So yeah, we have a function, so here is the function, by the way, that parses the lines, right? It parses them properly, but we'll need to test them on all of the lines here. So, and I'm not sure about var. I think you can just do things like that, don't you? I think you should be able to just do it like that and don't worry about it. Let me see. And yeah, I was right. So, cool. So, epic parsing. So the music is a little bit louder, right? What is going on? All right, let's continue. So what's gonna be the next thing? I want to actually read all of the lines from the file, right? All of the lines from the file, and just parse them and just print them, just to test all of that. So we already have a sample, if I understand correctly. So here's the sample. Cool. And in a make file, I'm going to do sample.txt. So here's the sample.txt. So go read file line by line. How do I do that? Read the file. Okay, Stack Overflow, my favorite one of all time. Okay, so we just open the file. Scanner? The fuck is this shit? There's a function in buff.io. Alright, read line, show me example, please. I want examples. Do I have to use this crappy stuff that is suggested here? I mean, I can. Really? Is there any better way? Is there any better way, please? New reader, buff.io, read string. Really? Okay. Well, I mean, okay, sure. Okay, let's go ahead and do that. So I still need OS then. Alright. Cozy White Bear, welcome to the streams. Hello, hello. So OS open. So I also want to, like, to be fair, I think it would be nice to like handle all of the errors. Is it possible to how would I do that? How do you panic and go? How do you panic and go? Go lang panic. Can I just panic with the error? If error happens. Panic. Show me panic, please. Show me the example of calling panic. Show me it. I don't care. Where is it? I don't see it. Okay, panic. That's what I'm talking about. All right. So if error not equal nil, can I panic with it? Right, like this. Is that a thing I can do? That's the only question I have here. Right, because I don't really want to handle anything. Okay, if it's so annoying. Okay, that works. Cool. If error not equal nil, I'll just want to panic with it. Whatever. Hopefully it will print all of the necessary information here. So also it's going to be open. Really? Do I not have to provide? I don't like this. I don't like this. It's Pepega. It's very Pepega way of doing these things. Okay, you don't provide the mode in which you open the file, right? Do I understand it correctly? I think you don't provide the mode. You just open it for whatever. Okay, so that's very strange. File path, and then we can defer closing the file, right? So it's gonna be close. Is it close? Oh, it's actually like this. All right, and after that we'll have to create a buffer.io new scanner. Buff.io. Oh my god, I'm a little bit. I need a little bit more tea. This parser is just a little bit too tedious to implement, but I mean, I already implemented it, so it doesn't really matter. So scanner, buff.io new scanner, and we'll have to provide the file, and then I can iterate through. Okay, so iterate through scanner. This is a really strange way of doing that. Scan, and we can iterate through lines. So here's the line. Scanner text. So I should be able to do this kind of stuff. Now line to rule like this, and then I can do the following thing: fmt print f v new. There we go. And do I need to do anything else? Do I need to do anything else? Maybe it would be nice to also check for the errors afterwards, because if any of the errors happen, I want the application to crash. I just want the application to crash. That's the only thing I want. Just indent it properly, please. Thank you very much. So this is a scanner, and I'm not going to do that. I'm going to straight up panic here, right? So if anything happened here, so that should be all right. There we go. So we parsed all of this, mother flippers. Look at that. Look at that. So this was a sample input, and we managed to parse all of them. So there we go. Isn't that cool? Isn't that cool? I think it's pretty fucking cool, mate. Yes, looking yes. What's funny is that maybe a single rule shouldn't be a structure. Maybe a rule should be a map from a color container, from a color container to a sequence of children. Yeah. So let me try to do that. So what if a rule was go lang map? This is not map slices. Google, stop being a smartass. I really hate when Google tries to be a smartass and autocomplete something that I don't need. It's just annoying. So, okay, so this thing could be something like a key type, and key type is going to be the color, and the value type is going to be child. So what if rule was something like this instead of that stinky structure? So we could easily look up the children for a specific color, right? So that would be actually pretty cool. So that will require changing some of this stuff, right? So changing some of this stuff. Actually, it's just a single thing. Like rule would be a single entry in this map, and this is actually like rules. Yes, it would be actually something like rules. Yeah, it would be something like rules, and this particular thing. Okay, I see. So I'm gonna keep it like that. And this is how we're gonna use all of that. Alright, so we iterate through each individual file. Oh my god, whew, this is really... It's like a running marathon. It's just a lot of things you need to implement. And we didn't even get to the essence of the problem yet. Right, so we're only parsing shit. Okay, so essentially I want to have something like rules. Right, we're gonna have rules, and it's gonna be a map from color to these children things. And I suppose I should be able to initialize it like that. Okay, so then I can take a rule like this, and I should be able to add that rule like this. I have no idea if it's gonna work. I have no idea if it is a correct Go syntax, but I'm gonna try. So, and after that, we're gonna do the following thing. Okay, rules children undefined. Really? Are you sure about this? Is because it's a single rule. There we go. So we build a map out of this shit now, right? So now we have this map where we can very easily look up all of this stuff. So it would be kind of cool to turn this into a separate function that returns these rules. Okay, one more time. So we're gonna introduce another type. It's gonna be rules like this. So file, and I'm gonna rename it to something like this, like rules from file, and it will return you rules, right? So here are the rules, and instead of doing them like that, it's gonna return the rules. And we're gonna have a separate function here, func solve file. It takes a file path, and what is rulesa? The fuck is rulesa? Okay, and I can do something like fmt printf, like that. Rules from file path, and let me see, syntax of top level. Yep, that's true. Cool. So now we have a separate function that just takes a file and returns just a map of all of the rules there. And we'll see if it's going to be useful for our particular case. Maybe we'll have to pre-process it or something, or maybe like reverse it somehow. We'll see. I wonder how many of them do you have in the input. Let me see. Let's actually get the input, just to get the gist of how many shit we need to parse. So here's the puzzle input, and it's not that much actually. It's actually pretty small input. So maybe we can even come up with a very dumb algorithm. Alright. Okay, so, and I can try to add this thing to the input. So it's gonna be input txt, and let's see how it's gonna go. Okay, so I mean Emacs cannot really handle all of that, but it's probably yeah, the encoding of the stream is probably also very big right now, but yeah. But can you have like a... So the reason why it's so slow is because it tries to print everything in single line. Go length pretty print. So if it was pretty printed, it would be a little bit faster, I think. Preprint structure and variables and Go. Don't tell me it's a third-party dependency. Don't tell me it's a third-party dependency. Please, 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 please don't tell me. Okay. So it's a plus. We'll print both fields and value. We'll print the struct name, but also both. Okay. Prediprint. Where's prediprint? Useless. Did anybody know? Is that something that I have to do, or just to... Okay, whatever. I'm gonna assume that it's impossible, because I couldn't quickly find it, so that means it's probably impossible. Without third-party dependencies, of course. Yes. With third-party dependency, you can do whatever the fuck you want, but we're not using third-party dependencies here. Alright, so what was the problem? I forgot. Like, alright, because, you know, the first part is to parse this bullshit, right? It's intentionally, like, provided in a completely unparsable format, so you waste your time just parsing this entire stuff. Okay, we're starting with a shiny gold. Alright. Then we need to find all of the bags which contain shiny legendary gold, right? That contain legendary gold, and we can put them into... Okay, so let me show you what I mean. I think we need to draw. I think we need to draw all of that. All right. So we'll also probably have to keep track of what we already visited and stuff like that, so that'll be interesting. Okay, so we start with the golden legendary, right? So then we realize that the golden legendary can be contained in, for example, these three, right? So that means we already have at least two paths. Right. So then you basically keep track of this sort of wave, right? And then you look at this one. So you know that this can be contained in that, and maybe this can be contained in that. And this is a terminal one, and this can be contained in that. So that means this one turns into two. So we have 1, 2, 3, and 4. Huh. I think I need to make a cup of tea because, yeah. So essentially, we can try to solve that as a BFS, right? At least try and see how it's gonna go. But I already been coding for 1 hour, and so it's time for me to make a break. Does anybody have any questions, by the way, while making a tea and stuff like that? Does anyone have any questions? I'm reading the chat. What number did you got in P1? What is P1? Problem 1? I have no idea. You can probably check out my source code here. You can literally like take, I post them in this repo, and yeah, maybe you can derive it from there. There's also my input there if you're interested. So I wonder if advanced code generates different. Yes, it does. So you could have just asked if it generates different input. Yes, it does. It's a fact. You don't need my like answer for that. You could have just asked that. What does defer keyword do in Go? It basically calls the code that you deferred at the end of the function. That's what it does. So essentially, it's quite useful when you work with resources, like you open a file, and then at the end of the function, you always want to be able to close that file. So you defer the closing of that file, and it will be automatically closed once you exit the function, or a panic will be thrown, so it doesn't matter. So this will guarantee that the file will be closed when you exit that function, no matter how you're gonna exit it, right? Make sense? So it's sort of like array AI, but array AI actually works on the level of like individual scopes, but as far as I know, defer in Go works only on the scope of the current function and not on individual scopes, so it's slightly different than like classical array AI in C++ and Rust. So at least, like, I'm not, you know, actively programming in Go, so I may not know some details on that. So yeah, I haven't programmed in Go for quite some time, so this is, yeah. Does anyone have any other questions? I'm just making tea. I'm taking a break because I've been coding for like 1 hour non-stop. And I need to reset my brain a little bit, right? So that's what I need to do. All right, I'm gonna really quickly go to the kitchen and turn on my kettle, super quick. And in the meantime, feel free to post your questions. And so it's gonna be like a couple of seconds, like 10 seconds probably. Yeah. Yo, what's up, epic gophers? How's it going? What's up? Oh, Nefli, hello. Welcome to the stream. So, by the way, can we graph with that bitch? That would be actually pretty cool. So here's the rules from file, and we can introduce something like func print graph graph with of rules, right? So like this is gonna accept the rules, right? Just rules. Nafla is currently in school. Back in my days, we didn't watch Twitch in school because Twitch didn't exist. That's how old I am. But anyway, I kind of envy you. If yeah, I would fucking definitely watch Twitch when I was in school. That's for fucking sure. Because school sucks. Fuck school. Anyway, so how are we gonna do that? Does anybody know how to use GraphWiz? Let's close all of this shit. Let's close all of this shit. GraphWiz. Closing tabs. Yeah, closing tabs feels so fucking good. Especially when you're done with your bullshit, right? And you close all of these tabs you don't need anymore. It's just... oof, love it. I need an example. GraphWiz example. Because I don't care about like reading about syntax, like I just want an example that I can replicate. So this is a dgraph, but I think, well, I mean, in our case, it's kind of a direct graph, so I guess that's okay. So it's going to be printf, and it's going to be dgraph d, right? Or maybe let's call them rules, right? So it's going to be rules, and this is the beginning and the end. You're using GraphWiz too. Well, I mean, yes, there's nothing special about using GraphWiz. I use GraphWiz quite often, actually. It's also very actively used by language developers. So they usually dump AST into GraphWiz and they just observe like visual representation of their AST. So it's actually a useful trick. Nothing to be ashamed of. Yeah, I wish the syntax was less weird, but I guess it's okay. It's okay for now. So I remember I could do something like this. So it's going to be S. I'll probably have to iterate through each individual rule there. Right, how do you iterate maps? How do you iterate maps? Okay, so it's going to be for rule in rules. It actually has to be a range of some sort. A range, right? So, and I just want to print this thing like this. It's going to be println. It's actually going to be printf. So, and I'm going to do it like that. Why are you... Nuffly? Did you change your nickname yet again? Stop changing your nicknames, Jesus fucking Christ. Hello, hello everyone. You're trusted now, so you should be able to post things. Okay, so let's take a look at what it will return. Oh shit, oh shit, oh fuck, oh fuck, oh fuck. Stop, stop. Okay, so let me quickly remove this thing from here. So we're gonna only use sample. So rules from file, yeah, so I'm gonna do print, print graph viz of rules. So that's how it's gonna go. Okay, so that works, but that gave me only the key. So I can do something like key value. Let me see. This is gonna be key, and this is. Come on, I really dislike how difficult to type this sequence of characters. Like, it's very unorganic, and you need to type it quite often because values you create but never use, because you always want to inspect some of these values. Yeah, there we go. This is what I'm talking about. So we're gonna have that and blah 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 blah. So after that we'll have to iterate through so this is going to be children. So this is a key, children, arrange like this. And this is going to be like this, right? Okay, I think I'm going to just keep doing it like that. So it's going to be key, child. And do you do anything at the end? Yeah, you put semicolon there. You put semicolon there. Okay. Oh, really? I think it has to be like child color. Wait, what the fuck does it return? Yeah, thank you. Yeah. Cool. But why does it? Okay, so now it works. Cool. Do I have to indent it? Right, cool. So that seems to be working. That seems to be twerking, which is super cool. Let me also do the following thing. Oh, you know what? We can do something very cool right now. Let's put it here. It would be cool to have like a separate executable that generates graphs and so on and so forth, but whatever. So rules. By the way, my tea is ready. Just a second. My tea is ready. What's up? That was good. I'm back. Parsing is very annoying. Okay, so how do you do that? Dot, I think PNG, rules dot. Oh shit, no, don't print it. Don't print it on fucking... It prints it on the standard output. Who would have fucking thought? Imagine like a tool that prints binary shit on a standard output by default. Fucking A. This is like everything that I hate about graphics. They always like choose these weird solutions. Doxed? What are you fucking talking about? Alright. Okay, that's interesting. It's acyclic, which is already fucking cool. It's acyclic. So we have shiny gold. So this is 1, 2, 3. All right, that makes sense. I'm just thinking about pitfalls in case of just as dumb BFS. If I'm gonna just apply a dumb BFS that goes up, right, that just simply goes up, will there be any pitfalls for me? I don't think so. I don't think there will be. So it's actually pretty straightforward. Yeah, okay. Cool. It will be pretty interesting to have like a separate, but I can do that afterwards. Hello everyone who just joined. So one of the operations we will need here is to take a caller, right, and find a caller that contains that caller. So what I mean here is something like who contains, right? Maybe not who, but I mean who contains. Maybe find container, and we provide the rules, right? Because you're gonna use the rules to find that, and we provide the caller. So, and what we're gonna return is another caller that contains that caller, right? That contains that caller, and an indication that we found it or not. So, is it Boolean? Right, I think it's Boolean, right? So this is basically what we're gonna have here. So, and so what we need to do is iterate through all of the rules. Actually, you may have several containers, right? You may have several containers, and because of that, you don't even need to do that, right? So find containers. So you have to do the reverse operation, and because of that, we don't really need rules to be a map, because for this kind of operation, we still need to iterate them line by line. It doesn't really matter that much, I think. So, and the input is not that big anyway, right? If you take a look at this input, it's not that big anyway, so I think such a dumb operation is going to be okay. And yeah, so we're gonna do that in a very dumb way. All right, so let me see how we iterate that. So print graph this is how we iterate the rules. Right, so this is how we iterate the rules. And then we need to check if the children contain this caller. We'll have to add this container. So we're gonna call it container. Container, and we're gonna introduce something like result. Result, and this is essentially a bunch of colors. A bunch of colors, like for children, for child, children, not in, it's actually range, right? In children, and so if child color equal color. Can you compare strings like that? I think you should be able to compare strings like that. You do result equal append result, and we just append the container, and then we break out of the loop. Kingslayer, oh my god, resubed for 16 months. Thank you so much for 16 months of tier 1 subscription, and welcome back to our epic Gopher Clap. How about that? 16 months in a Gopher Clap. That's a pretty long time. Welcome. Alright, and after that, hello Night MT, welcome. And then we're gonna just return. I think this is as simple as that. So find containers, you find all of the containers, and you get all of these containers of this thing. Pretty goddamn straightforward. Yeah, let me see if this compiles. Maybe I'm gonna just try to compile only main. Missing body. Function. I know what's going on. Very useful error message go, by the way. Thank you so much. Okay, so this does compile. So let's go back to find solve file. Okay, so we have rules here. So here are the rules. And where do we have a start? Start is golden legendary, right? Is it not? I think it is. Golden legendary. Here it is. Shiny gold. And what I want to do, find containers. I'm going to provide the rules, I provide start, and let's just bring them and see who contains those motherflippers. Who contains them? Should be pretty straightforward. This is not how I'm going to run it. There we go. So bright muted yellow contain this kind of stuff. You know what's interesting is that we can repeat this operation on these elements yet again. So let me show you something. Let me show you something. Let's introduce a function. So we already have find containers. We can do something like find containers containers of containers, right? So essentially you take the rules. It's such a dumb solution, but instead of like color, a single color, you have several of them, right? So you have something like this, and you get something like this. So, and you have a result that looks like this. Color, there we go. Can you concatenate two arrays? Well, recursion would be, yeah, I think recursion would be actually pretty useful here. Maybe we should do that recursively, because that will probably allocate less memory. Yeah, I was trying to like solve it in a Haskell way. In a Haskell way, you would actually do that like by slices, like, and in a very monadic way. So, but I think in Go, this approach is not really gonna fly. So, yeah, I'm gonna have to do it recursively. In Haskell, it would be so fucking elegant, believe it or not. Like, so you would be able to treat lists as monad, and then you would, oh my god, that would be so cool. But unfortunately, we already wasted Haskell on a different problem. Stack Overflow, I don't think so. First of all, the input is not that big, so I don't think it's gonna be too deep. I don't think it's gonna be too deep. And if it's too deep, we can try to increase the stack. It will actually depend. So we may try to graph the input and just see how deep it is. Oh, yeah, by the way, we need to perform the usual TSMR because my tea is ready. In just a second, chat, are you fucking ready for TSMR? There we go. Okay, cool. Alrighty. So, are you doing? Yeah, check out my repo. So, you can see that. So today's Go. I don't know which language we're gonna use tomorrow. So, I still have a camel and C. Don't want to waste them on simple problems. Probably gonna use them for more difficult one. You were not ready? Well, sorry. So let me think. We have Raiders from Rayleigh Mundane. I hope I'm pronouncing your name correctly. Welcome, welcome. Welcome, Raiders. So to be fair, but okay, so people saying that maybe recursion is going to be kind of dangerous, but we can do that without recursion. Yeah, let's try to do that without recursion with the dumb approach that I wanted. Find containers. So find many containers. I think it would be actually kind of cool. Find many containers. Yeah. So let's go with a non-recursive approach. Rules, which will probably generate a lot of memory, but I mean, it's 2020. Memory is cheap. Don't even worry about that. Color like this. So we're gonna iterate through all of the. So these are supposed to be colors, right? So colors. Really mundane. Oh, I see. Okay. I'll try to keep that in mind. So, and then we find the containers of that specific color. And then we have to concatenate them back to result. And I wonder how it's gonna work. I'm not sure if append is gonna work like this. So maybe there's something like concat. Maybe. So go lang concat arrays. Let me see. 2 slices in Go. Oh, you can just use append. Okay, cool. That's cool. Thank you, Google. Very cool. I really like that it's like Go is so popular that you can literally Google anything and find answer. It's kind of difficult to Google such things with less popular languages because nobody uses them, so you actually have to read documentation, as an opposite somebody reading documentation for you. Okay, so yeah, essentially we have higher order find containers now. And we can just return this result. So should carry step forward. So the complexity of this motherfucker is insane. My god. Complexity is insane. Maybe we should actually build a reversed map to speed things up. But I'm not sure if that would be necessary. Not sure how necessary that would be. So if the result is going to be too slow, we'll have to build a reverse map. So we'll have to reverse the arrows for the graph to make it a little bit faster. So because the graph works like that, but we want to, so we see it goes down, but we want to go up, right? We really want to go up. So, and to do that, we'll have to do a little bit of preparation of reversing these arrows and building like a reverse map. And I'm not sure if it's going to be worth it for now. That's why I implemented a very dumb solution. Okay, so what I'm gonna do, so we have a start. Let's go with a wave. How do we stop? What's the indication of stop? The indication of stop would be if all of the elements in the wave are empty arrays. So that's what we're gonna do. Right, is stop wave. Right, so we're gonna have a wave which is a bunch of colors and it will return as boolean, right? So this is very dumb solution. So initially it returns true, but if we try to iterate, color in, why do I keep doing in range? If color, how do you take the length of the array? Is that how we do that? Greater than 0, return false. Wait, no. So, yeah. And we're also concatenating them. And we're also concatenating them. Are we looking for the maximum value? We're looking for the maximum value. Let me go back to here. So we're gonna have 3, and then it's gonna go to 3, but an amount of them 1, 2, 3. So this one was 1, became 3. Nah, let's do it recursively. I think my idea is super dumb. Let's do it recursively. Fuck that. Yeah, it's not gonna really fly. What is very specific in using Go to solve this? You're missing the point. Welcome to Tsoding channel. All right. So let's do something like count ways. For a particular, yeah, we're gonna have a fuller color. Count ways. Just flip the tree. What are you talking about? We don't even have tree. Like, I don't know if you know anything about graph theory. This is not a tree. This is not how a tree looks like. I'm sorry. Sorry to tell you. But I think somebody has to tell you that. Count ways. All right. So that means we'll have to return int. Okay, containers. Containers are gonna be find containers. Right here are the containers. We also have to accept the rules, right? So we have to accept the rules. So this is the rules, and we're finding the containers for this specific thing. And we're gonna have two situations when the amount of containers is actually 0. All right, so if it's greater, we're gonna do one thing. If it's not, I guess there is one way to do that because color exists, so we can return 1. Otherwise, we have to sum up the ways for each individual container. So for container in containers, it has to be a range. 2 to the 2, and we're gonna have something like a result. We might as well actually have a result here equal. It could be somewhere here. Let's put it like that. Result plus equal count ways rules container, a single one, and of course this thing has to be like this, obviously. Okay, so now we can try to do that and see how if it's gonna fail or not. So this is a shiny gold. So count ways. So this is only the first part, by the way. I wonder how the second part, how much the second part is gonna fuck up our thing. Right, so yeah, we'll see how much it will fuck up. All right, because we'll probably have to, you know, rewrite a lot of stuff. I already written like 110 lines of code just to parse and traverse and shit like that. Missing return at the end. Is that what you want? Yeah. And we can do it like that. Not enough arguments. Cool. I have to provide the rules. And are we ready? Okay, so 4. Is that the correct answer, motherfucker? Yes. This is the correct answer. How about that? How about that? Maybe I do know something about recursion and graphs. Who would have fucking thought? Alrighty. So let's see if we can apply that to the whole input. And by the way, so we're showing this input, and I also want to print something like print f. I want to print the file path that we are currently processing, right? So input file is going to be this, and this is a file path. Continuing processing is going to tell me input file sample.txt part 1 4. Okay, I'm going to enable the input.txt. So here is my input. It's pretty big. I'm not sure if it's going to work. Maybe it's going to actually stall for several minutes, and we'll have to try to optimize that. But that's going to be like a pretty interesting exercise, I think. Anyways, so are you guys ready? Are you guys ready for an actual input? Okay, that was fast. Oh shit, it's not the right answer. Yeah, if you're stuck, make sure you're using full input data. There's also some general tips on the about page. Okay, so maybe I missed something. I'm not sure if I'm if I actually miss something. So input data. So maybe my approach is completely incorrect. It's kind of strange. So how can this thing fail? To be fair, if we cannot find any containers for that thing, maybe it's not a one, right? Where did I make a logical mistake? Duplicates. What's wrong with duplicates? It's an acyclic graph, if I understand correctly. Is it a cyclic graph? I think it is a cyclic graph. So, oh, by the way, what's funny is that, yeah, it shouldn't be that difficult of a problem, so it shouldn't be. Yeah, so that means like it doesn't really matter that much. Let's try to visualize this thing. So we're gonna try to solve. By the way, can I, for each file, so if I have like print graph width, where was graph width? Did I wait a second, did I remove graph width? How did I remove it? What the fuck? Is that because I fucking removed it apparently? Fucking removed it apparently. That's actually sad. How did that happen? This is so sad. Alright. Well, at least I know that this approach is actually not that slow, so we can use it for actual production. So let me try to rewrite a print graph width one more time. So let me try another thing as well. Func create graph create dot file for rules. Right, so we're gonna accept the rules. We're gonna accept the rules, and we're gonna create accept the file path. We're gonna accept the file path, and hopefully that thing will be able to do this kind of stuff. So I want to open a file. So OS open. Yeah. So file error. File error OS open. Come on. File path, right, and then if error not equal nil, we're gonna straight up panic, right, we're gonna panic with this error. After that, I'm gonna do the following thing, f print, we also have to defer closing this file, so it's gonna be close. Is this how I close it, right? Yeah, this is how we call it. It's actually like this one. Okay, printf, and I think I have to use the file and dgraph. How can I do that? Let's call it d, whatever, like this. And then we're gonna close it like that. So the reason why I want to do that. So here's the file path, and before doing anything, I also want to create .file for rules. Like we read the rules. Rules. I'm going to do file path plus dot. There we go. So by running a solution for a specific file, we also automatically generate the dot files, so we can always take a look at them. I think it's going to be very convenient. So it's going to do that automatically for us. All right, so we're going to iterate through the rules. So it's going to be a container and then children, range rules. For child range children, for child range children, and we're gonna do fnt fprintf file 1 2 3 4. It's gonna be something like this to something like this. We have a container. We might as well call it a parent. Then we're gonna have a child caller. There we go, and we're gonna have a new line here. We're gonna have a new line, and let's see if it's gonna work or not. Okay, fmt fprint printf, and something went wrong. So open file, no such file. I think it's called slightly differently, right? For a different regime of opening the file, golang open file for writing. Writing files. Okay. Create. It's called create. Okay. Called it. Fucking called it. All right. So on top of that, it also generated these kind of things, right? You see? It also generated them. Now, I want to do the following thing. In the make here, right? In the make here, we'll do the following thing. PNG dot, right? And I'm gonna do dot PNG. The input is gonna be that, and the output is going to be generated to this. So this is a phony target test. But also on top of that, we're going to have something like all, which does the test and the PNGs, I suppose. So the PNGs are pretty much this, but with this. Yeah, and hopefully that will automatically trigger everything that we need. So it not only was gonna like run everything, it will also generate the PNGs, right? It will also generate the PNGs. Okay, that didn't work for some reason. What the fuck? Oh yeah, this is because it has to be like $1. Excuse me. Okay. Oh shit! It's generating. It's actually taking so much time to generate that. What the fuck? Like, I mean, it's not that hard to generate. Come on. I mean, it's generating like for the input. I don't think it's a good idea. Well, I mean, okay, it's managed to finish that. Yeah, let's take a look. It's probably going to be super huge. So here's the input. It's 1,000, like 1,500 lines. And okay, so let's open it in Chromium then. Okay, that's fucking huge. Yeah, that's fucking huge. So it's kind of useless. That's definitely useless. Cool. But the sample one, it's at least useful. At least useful. So I don't quite understand, like, how can we even have duplicates here? Like, what's the problem with the duplicates? Duplicates may occur if you have some sort of a loops. Do you have directly acyclic graphs? You may have them, by the way. Okay, so if I read carefully, okay, you land okay, due to recent aviation regulation, many rules are being enforced about bags and their contents. Bags might be colored and must contain specific quantities of other color bag. Apparently nobody responsible. For example, I see the following rules. This will specify the required contents of 9 bags. To be fair, they don't say that it couldn't be cyclic, right? Right. But if it would be cyclic, the execution for my particular case would never stop, right? It would never stop. So yeah, because it stops, I make an assumption that yeah, it's not really cyclic, so that means this problem shouldn't be present. So the only problem, like if you have this one, all right, it's backs all the way down, yeah. 1, 2, so that gives you 2 ways. This is 1 way. This is still 1 way. This is still 1 way, and it will give you 1 way. So I don't see any problems in that. It's bags all the way down. Is that the quote? It's bags all. Why do you saying it like it's a quote? It's not a okay. It's they never said it, so it's just something that you came up with. How many at least shiny bag? So and they say that it's big, but I cannot see like I cannot see why would that approach be incorrect? Right. So we go up. There's 2. Okay, and for that one there's 1. There's 1 and 1, 2. So we have 2 here, and then you have 2 here. Literally, we have a duplicate situation here. 2 plus 2 is going to be 1. 2 plus 2 is going to be 1. So that approach makes sense here. Like, I don't understand why it wouldn't. Why it wouldn't. Let me try it one more time. Did I maybe parse it incorrectly? That could be the case, but I don't think I parsed it incorrectly, because if you take a look at the dot file, like, it looks okay. Right, I don't see anything like special here, anything weird. It just looks so okay. Let me read that one more time. You land at the regional airport in the time for your next flight. In fact, okay. The tourist and aviation regulations are being enforced about bags, their contents. Bags must contain color-coded, must be contain specific quantities of other color content. Apparently nobody responsible for these regulations considered who would take. I'm missing something very stupid. I'm pretty sure about that. For example, these are the rules. These rules specify the required contents for 9 bag types. In this example, every faded blue bag is empty, every and so on. You have shiny gold. If you want to carry it in at least one other bag, how many different bags would be valid for the outermost bag? Outermost bag. In other words, how many bags can eventually contain at least one shiny bag? Right, in the above example, the following options would be available to you. So in this example, the number of bags colors that can eventually contain at least is 4. Wait a fucking second. Oh shit, I misunderstood the... Fuck. Yes, I missed some... Okay, I misunderstood. I misunderstood the problem. Shit. Okay. Oh shit. We have 4 of them because 1, 2, 3, 4. That's the 4. God fucking damn. I thought I need to calculate the amount of paths to the route. So here's the first path. Here's the second path. Here's the third path. And here's the fourth path. And it coincidentally also equal to 4. Yes, that's the problem. I misunderstood the description. Fucking description. Jesus fucking Christ. Ah, fuck me. I was solving the wrong problem. Okay, I see now. All right. So that's my fault. That's totally my fault. So, okay. Makes sense. So that is a little bit easier to solve, I think, because yeah, you need some sort of a set that will just maintain these things as you basically travel a lot. That's even easier. God fucking damn it. That's just even easier. you think about it. Do we have like queues? So essentially you just need to compute how many other bags you visited while traveling up. That's even fucking easy. You don't even need any fucking recursion. Okay, I wish I only understood it correctly first time. You misunderstood it as well yesterday. Okay, so descriptions are very nice. So the real problems in Advent of Code are not the problems themselves, but trying to understand what the fuck the author wants from us. That's the real problem. All right, so let me see. Desk Go has a convenient queue, so maybe with the queue we can do something. The two basic FIFO, maybe you can use a channel. Why do we have, okay, it's a representation of a queue. Cool. You can append, so in queue. Okay. Watch out for memory leaks. Erase elements. Okay, you can have container list. Maybe we can just use list. So is that something that comes with the implements a double linked list, which can be used as a queue? Queue front element you can push back, and you can dequeue. There is a queue in std lib. So why couldn't I find it? You mean list or queue? There's a package queue. This doesn't look. You mean list, right? That's what you mean. You mean list, or there's literally a queue. I don't know, because I found the queue. Like I typed Google queue and I found list. Okay, so I'm gonna use list because I don't know what you're trying to tell me. Okay. So let's try to channel. I mean, channel is for thread communication, and I think it's a good idea to use it here. Container list. Is it container list? Yeah. Oof, I made a mistake. It was a third-party package on some. Yeah, okay. Because I'm pretty sure if it did have queue in standard library, I would instantly find it on Google. Since I didn't find it, well, we were probably gonna use lists. So okay. By the way, let me remove all of that dot bullshit. I don't think it's actually worth it. I don't think it's actually worth it. But yeah, there we go. Container list, and we don't have it. Container list. It's also third-party dependency, right? So it's also third-party dependency. Get for container. All right, so that means we only have slices, right? We only have slices, and they have some sort of a warning for watch out for memory. You may want to remove the first element before dequeuing. Oh, that's very interesting. Oh shit. Okay, cool. But why didn't you put that in the example above then? If it's so important, why didn't you put it there? Why did you separate it from? Oh, god damn it! Okay. I'm starting to actually make very stupid mistakes. Okay. I'm sorry, chat. Yeah, because I'm already programming this problem for 2 hours, right? So yeah, I'm not even sure if solving this stuff on stream is worth it. But yeah, let's actually finish it. Okay, so we do have it then. So we create .files just in case, then we count ways, but we not really count ways in that regard, right? We can still call it count ways. Yeah, so we have, we don't need to do that. So, queue list. It's actually list new, so we create a new list here, and we're gonna push back the caller here. So will it automatically derive the type for me? How does it know the type? It doesn't know the type. It doesn't know the type. Sure. Okay, While for q, do I use like okay, I do use it like that. Q len greater than 0, but while we have all of that here, so we're gonna have visited go lang set, two basic set implementations. So you use map void for the set. All right, so visited this. All right, and we're gonna push this entire stuff. I'm gonna push back caller, and I think I'm gonna add visited. Add. Really? This is such a weird way of doing sets. Is this an official way of doing sets in Go? Really? Shit, bruh. Okay. I'm not gonna even fucking question that. I think Boolean may be a little bit easier in this particular case. With empty struct values. Okay, we can use Boolean then, whatever. Visited caller, and I'm gonna just say that it's true, right? So we visited that. And at some point we'll probably have to take this. Yeah, I'm just a little bit like, I have a cultural shock coming from, you know, proper programming languages. I have a little bit of a cultural shock. Okay, so, but I can get used to that. I think I can get used to that. So this is true. And so then I need to dequeue a thing. How do you dequeue it? How do you dequeue it? You remove, yeah, you first you do front. So this is a front. It's gonna be next. Right, and then we remove it from a queue. Wait a second, seriously? You have to provide this element here to remove it, so that kind of implies that it's gonna remove it in O of n. Why do you do? Well, I mean, it's not going to be O of n because it's going to go from left to right and remove it, but this looks so fucking scuffed. Like, oh my god, it's like a... Oh, are you fucking serious? Like, this is so bad. Like, who came up with this? Oh my god, I'm so sad. This hurts, like... You see what I'm talking about? You see what I'm talking about? To dequeue, you remove next. To remove from the beginning, you have to provide the element. So that implies that remove is O of n, but it's not gonna be O of n because it's the first one. That's why it is okay solution. So it's like this sort of a hack. You fucking serious, bro? Dude. This is like a PHP level of language design decision. Anyway. Shouldn't be just a pop. I don't know, maybe the author came up with something scuffed here. Pop. Remove E from if A is element of list returns value. There's literally no pop. There's literally no pop. You can do push back. No. Anyway, let's not back shit. So here's the front. So we have the next element. Essentially, if we never visited that element, well, I mean, yeah, this is what we need to do here. If, how can I check if a set contains a go lang map check if contains? How to check if map contains a key? Come on, come on, come on. So if visited next, okay. If it's already visited, actually, if not visited, right? If it's not visited, we're going to take its for child in find container range find containers for that next, and we're gonna push all of them into the queue. So we push back container like this, yeah, and we're gonna push all of them. After that, we're gonna mark this thing as visited and continue. So we're gonna have this like a BFS. So we add the color, then take the next. If it's not visited, right, it's not visited, we take its containers, its possible containers, and we push them in there. Push them in there, and we continue. Okay. After that, we should take the length of the visited. We take the length of the visited, and what's interesting is that we should not include, because the question is what? How many bags can eventually contain at least one shiny bag? Yeah. So that means it's going to be length minus 1. It's going to be length minus 1. Does it make sense? So this is just a regular BFS, nothing special. Like it's imperative BFS, I would even say. Count bags. Let's go with count bags. Doesn't come. Okay. So next. So it's a front. So that means the front returns what? Map index. Wait, what? Is that? Oh, it's a value? Okay. Alright, I didn't... Oh, okay. So it's like a pointer or something. Cannot... Dude, what the fuck is going on? Okay. Do I have to cast it to... I think I have to cast it. Go cast... The scuffed language. Why is this so scuffed? Okay. Okay, so do I have to put parentheses? Why do they put parentheses here? I don't understand. And then, okay, so can I do string then? Oh shit. Dude, what do you want from me? Dude, what do you want from me? Like, why? What do you want from me? Like, how do I do that? I just follow it and... This is so bad. Oh my fucking goodness. I just want a queue. Oh my god, this is so bad. Alright, so let's do the different thing. So I do need the parentheses because like it's so scuffed. Okay, and shit, it's so bad. Oh shit, like, shit tier language. Okay, and we also have to provide the rules. It's disgusting. This is the most disgusting thing I've ever seen in my life. Jesus Christ. Alright, and I have to just do this stuff like all over again. Oh shit. Okay, and it of course failed because why? Is int not string? Oh shit, it's so fucking bad. Fuck lists. We're not gonna use lists. Ah, this is so bad. Okay, so this is not gonna be list. Let's do like a color. Yeah, by the way, these things has to be color. We're gonna do it like that. And I'm not sure if it's gonna be too slow. Q, what was that? This is the color. Okay, so we're gonna append it like that. And this is really fucking bad. Like, I'm just afraid. I'm really afraid with slices because I think it's gonna be too slow. That's why I don't want to use them. So that's why I want to just try to do it like that. So yeah. I still want to do the container list. Still want to actually solve that problem. Solve this thing. Is int not string? Why is it int? Okay, so that's the good question here. Why is it int? Why is it int? I'm willing to bet slices will be a lot faster. Why? Why would they be a lot faster? Why exactly? Because isn't gonna like reallocate a shit ton of memory every time I push and pop? Because that's what it feels like. At least, like, I don't know how exactly Go implements them, but that's what it feels like. And why is it int? Like, I don't understand why would it be int? Because I push color there, which is string. Why on earth this thing is gonna be... Oh shit, oh my god, this is fucking... this for shit always debates me, like, oh my god. Ugh. Fucking for shit, it's so fucking bad. Okay, so... Yes, it solves it, and... Okay, let's see if this one is the correct one, because this time I hopefully understood the problem correctly, and the previous solution, I should have actually solved the previous solution just to see, but I think it was around 340 or something. This one looks way smaller, so I think the answer is going to be that, and oh, yeah, I think it technically first try. Technically, it is first try because the first time I didn't understand the solution correctly, or the problem correctly, right? So I was solving a different problem. So once I understood it, like a completely new, fresh problem, that new, fresh problem, it's first try. So technically, it is first try. So yes, got cooler, by the way, got cooler. But this is only the first part, so. So what's fun is that first part does not even involve amounts, right? It doesn't involve amounts, but we still have amounts. And I know, like I already had that before, so they usually introduce some useless stuff that you probably don't want to parse, right? But it's going to be used in the second part. So, and I already parsed it. So I already have amounts, they're already there, so I don't have to parse them. Everything's okay. So I wonder if that will help me with the part 2. By the way, this is my raw, unfiltered reaction to this problem. Like, I didn't even read that problem before. So I have no idea what's gonna await me in the part 2. Let's find out. Oh shit. Okay. So, of course, as I mentioned, they involve the amount of bags and stuff. Okay, let me just catch my breath. React streamer, by the way. Yes, React streamer. Oh my god. Look, by the way, I like how... Actually, I dislike how Go is a strongly statically typed compiled language until you start doing containers. Once you start doing containers, all of its type systems goes to complete fucking shit and you're programming in Python. It's just amazing, and that happens super fucking quickly. You're thinking that you're programming in like a very strong statically typed language that you can rely on. Generic containers, go fuck yourself, you're programming in Python. Like it's so bad. It's just amazing, I don't know. Okay. Is Rust more polished? I would say it's more finished. Anyway, it's getting pretty expensive to fly these days, not because of ticket prices, but because of the ridiculous number of bags you need to buy. Consider again your shiny legendary gold bag and the rules from the above example. Okay, so faded blue bags contain 0 other bags. Dotted bags contain blah blah blah. The brown bags contain other bags. Okay, so the shiny gold bag must contain 1 dark olive bag, and the 7 bags within it plus 2 Robertson plum bags, and the 11. So okay, so you need to calculate how many bags a particular bag can contain. Oh, that's actually kind of cool. So in the part 2, we were traversing the graph up, right? We were traversing it up, and I think for this one we're going to be traversing it down. That's actually a pretty cool idea. That's actually a pretty cool idea. So the first one is up and the second one is down. Of course, the actual rules have a small chance of going several levels deeper than this example. Be sure to count all of the bags, even the nesting becomes topologically impractical. So here's another example. Shiny gold bags contain 2 dark. In this example, the shiny gold bag must contain 126 other. How many individual bags are required inside your single shiny gold bag? All right, this one is easy actually. So this one you can just go down. So, but in the previous one we had to go up. All right. So, so here is the count bags. Oh, what's up, Odin? Welcome. How are you doing? 2 is gonna be count bag version 1. It's gonna be a version 1. So let's compute, let's actually create the alternative function. So this is gonna be a version 2, and let's return like 69 for now. Oh, maybe let's 0. And I'm gonna create a second part here. I'm gonna create a second part. So this is the second part, and this is the version 2. So we might as well also do sample. So let me rename the sample to 01. To 01. 01. 02. And I just want to include that second sample there too. Let's try to run them. Okay, cool. So here's the sample 1, sample 2. That's really interesting that for the sample 2 is just yeah, because probably for the sample 2 shiny gold bag doesn't have any containers. Yeah, so that's why it returns 0. So that makes sense. So let's go and implement bags version 2. Okay. Should be pretty straightforward because for the rules we'll have to do color, and since it's a map, it gives us the children, right? It gives us the children. How many individual bags it should contain. If we find a bag that doesn't contain anything, we should return probably 1. Yes. So okay, if so this is the value, so this is the children. Okay, this is the children, and okay, if okay, right, if okay, something like this, right? If we have children, that means we're gonna iterate them. So we also have to keep track of the result, right? We have to keep track of the result. So result is going to be initially 1, so we're going to contain at least one bag. So here is the result. And we need to iterate the children. So child, children, and what we're going to have here. So a child can, as far as I know, like a struct child, right, contains a color and a mount. So we can do things recursively. So this is going to be rules, then child color, right? So child color. The empty bag that doesn't contain anything will return probably 1 because of this result thingy here. And we actually sum them up. Yes, we do sum them up. This one is interesting, actually. In case of an empty situation, right? In case of an empty situation, eventually, we might try to straight up return 0, straight up return 1. Right, but for things that do have children, we have to do something like this. It's going to be result. So I think it's going to be a little bit more correct. So, and then we do +1, +1, child amount multiplied by this one. Should be pretty straightforward. Interestingly enough, I think that will work. Yeah. So, child, did I do that? Yeah. God damn it, it debates me every time. God fucking damn it. Oh, right, and it did nothing. Cool. I wonder why. It did nothing. The fuck? Still returns 0. So if we find a caller that doesn't have any children, we're always going to return 1. Okay, let me try to read that one more time. So a single shiny bug must contain 1 Dorkable bug and 7 other +2 bugs, and the 11 bugs those. Of course, the actual rules. It's just my brain is really tired right now. Maybe we can try to, so here's the second example. So we have a second sample. I can try to do a tpng on that thing, and I can redirect that to here. Just take a look at what it's gonna look like. So here it is. It doesn't increase it, right? It doesn't increase it. Okay, cool. Dark violet is gonna be is not gonna contain anything. That's why it's gonna return 1. Then it's gonna multiply 1 by 1. So it actually, okay, that's really strange. I need to calculate all of them. +1 as well. +1. I don't count the bag itself. I don't count the bags themselves. Okay. So if we, so this is 0, right? So doesn't contain anything. Then we have amount. Okay, so the bags themselves plus whatever they contain. That makes sense, I think. Yeah. The bags. Okay, so that actually means that I can get rid of this stuff. Okay, so it's actually pretty cool that I implemented this graph with stuff, because I'm a visual person, like I don't understand text stuff, but if I can just, you know, draw that, it makes it really obvious for me how to do that. And we also have for all of them, it's just I have to do that manually. Right, so this is the first sample. Yeah, and it actually helped immensely. I'm not sure if I pronounced that word correctly, but I tried at least. Okay, and then we should be able to do that, and hopefully that will work. So we're gonna do -b, and all right, that is very interesting. The fuck? I mean, we don't take into account amounts, so that's fair enough, but it's correct. 126 at least. 126. And here it is. For the sample, it's 126, and for our input, this should be the answer. Let's find out. Fucking solved. Fucking solved. How about that? Look, this time it was first try. This time with the first try. That's pretty cool. Who's the gut cooler here? It took me 2.5 hours. What the fuck? Anonymous Cheer, thank you. Thank you so much for 100 bits. Thank you, thank you, thank you. So here's the thing, like, I mean, the problems are not that hard. It's just, they take too much time of my stream and I have other projects to do. But on the other hand, people seem to like this kind of stuff, so maybe I'm gonna continue doing that, I don't know. No, we're not doing day 8. I actually intentionally lagging behind, so people have time to solve the problem, so I don't spoil anything or whatever, right? So that's why I'm lagging behind 1 day. Anyways, so let's actually do a committee. So this is the 7th day, so what is this? Untracked files, whatever. I was about how do you configure Emacs, etc. I would like to start using Emacs, but it's hard. You don't need to use Emacs to become a better programmer. So, but like you can use any text editor, and that literally has zero effect on how good of a programmer you are. Seriously, don't think about it. Let me see. I think I want to git ignore some of this stuff. So I'm going to quickly git ignore. Specifically .files and PNG files. And do we need anything else? I also need to git ignore main. But for example, to input Japanese characters, it's easier to do it in Emacs. I don't know, like I don't usually input Japanese characters in Emacs, I'm sorry. So I'm wrong person to ask about this kind of stuff. Okay, so so let's also introduce README, by the way. So I'm trying to get into the habit of introducing like READMEs to each individual solution here. So it's going to be day 7 solution in Go, right? And I usually give the links to the corresponding problems, and the languages, Go lang. So people, this is not what I want. Okay, I think this is kind of what I wanted. Okay, so let's put it like that. So quick start. Please back that statement up by coding in Word for the rest of the stream, today's stream. No. Okay. Okay, so what we have to do. So the first step is going to be install Go, and can we go to the download? Where can I download this shit? Okay, so here install Go, and make sure Go is available. Is that how we spell it? Available in path, right? And then make. there we go. So this is like a quick instructions for people to follow. Yep. So this is my input, and there we go. 07 add solution for day 7. I'm gonna push that right into the repo. There we go, there we go. Yeah, my repo is available here. But what if I don't have make on my Windows 11? You'll have to install it as well. To be fair, like, there's a lot of things that are required to build this stuff. For example, I don't know, to have bash, do I have to document it as well? So we always have to, you know, think where to stop documenting, you know, things. I think make is sort of implied. So we can take a look at the source code here. Yeah, so all my solutions that I solved on the stream, by the way, are available there. There's also a playlist on YouTube with my streams where I solve the Advent of Code problems. You can find them there. So yeah, and all of that is under MIT license. So this is all of the languages we use so far. D, Go, C++, Rust, Java, Haskell, and yeah, other. I suppose other is the make files and the text files, but yeah, so here's the language. We did that in D, yes. So I'll need to think what's going to be the tomorrow's language. That's a big D you got there. Yeah, actually D is the biggest one. Would you look at that? D is the biggest one. So that's kind of awkward. I was planning to actually continue my Rust development after Go. I still want to do that, to be fair. I still want to do that, but I'm already a little bit tired. So, okay. Yeah. So we're done with Advent of Code for today, right? And what we're gonna start doing for the rest of the stream, so I'm gonna try to solve at least one issue. We're gonna continue developing our TUI framework in Rust. So if you're interested in Rust programming and user interfaces, please stay, because we're switching to that. So we're gonna continue developing this thing, which is not this thing. I not copy pasted it properly. I'm sorry. So here's this one. And yeah, so essentially it's just a UI framework. It's kind of like a, I suppose, looks like Flutter. Some people mention that it looks like Flutter, but essentially you declaratively describe UI and you give that UI tree that you declaratively describe to the engine, and it just renders that for you, essentially. So, and yeah, this is what I want to continue developing after Advent of Code. We're going to solve 8th day tomorrow, so stay tuned and don't forget to, you know, join tomorrow and also follow and notification and stuff like that. So if you don't want to miss the 8th day, I'm not even sure if I'll be able to solve the 8th day. We'll see. Okay, so here is the thing we're developing. So we have a bunch of examples of the UI. The most interesting one is probably transfer list. So it's going to be cargo run example. There we go. So this is the kind of UIs you can develop with this framework. So far, it's a new framework, but you can have like 2 lists, and you can, for example, transfer elements from one list to another. And yeah, you can code that quite easily with the following amount of code. Right, with the following amount of code. So this basically describes a single list that you can control. This adds a title, and this combines 2 lists together. So this is the entire code for that example. It's completely declarative and it's in Rust. So yeah, that's what we're gonna do today. Let me change the title. So so what should we put in the title? Flutter. Okay, so let's put it this way: Flutter clone for TUI in Rust. I think it's a pretty pretty good title. I was planning to use that title today. So yeah, it's basically what we're doing. It's Flutter clone for TUI in Rust. Because it, well, Fengqi said that it looks like Flutter, so I'm gonna go with Zim, and I'm gonna say that it's, you know, Flutter inspired. So okay, today we are developing Flutter clone for TUI in Rust, and the source code is going to be available where is going to be available? It's going to be available there. Forgot to mention that you use Linux that requires for programming stream. Yeah, that's quite important. So maybe I'm not going to do that right now. So did I miss anything? Did I miss anything? Hopefully I didn't. Okay, the project has been updated. There we go. A title has been updated, the project has been updated, and let me do a small break. So I'm gonna do a small break for 3 minutes. I need to refill my water, I need to pee and everything, and we're gonna continue. There we go. All right, get ready for the break. Get ready for the break. Yo, what's up, Epic Gamers? Welcome back. So yeah, after a small break, we're gonna continue developing this thing. So, by the way, I just realized that we have a pull request for this thing. So let's take a look. So we now have a CI job. Thank you to 8342. Let me quickly check it out. So apparently our framework is going to work on Windows as well, which is quite exciting, right? It's cross-platform framework. Okay, let me take a look at it. So what do we add here? Test Unix, so a little bit of renaming. Okay, so also some name stuff. Test Windows. Looks okay. So we're using Windows latest. We're using latest Windows for this kind of thing. Let me take a look at the log of this thing. So Windows. Oh, that's kind of cool. Like Unix Windows. It's pretty cool. Okay, so when we build this thing, does it build anything properly? Yeah, looks cool. All right, so let me merge that. Looks good to me. Thumbs up. Thank you for your contribution. There we go. And merge the pull request. Thank you, thank you, thank you. So now we also test all of that on Windows. So this framework works both on Unix and Windows. Hopefully. All right. So what's going to be the next issues? Did I have have anything planned for today? So I'm not going to solve too much. Doesn't wrap during rendering. We want to check if it builds in Windows. I mean, as they say, if it compiles, it works. It's Rust after all. So I think I have like a, so I had a very simple issue. Right. So recently we started to develop a component for this UI system, which is edit field, right? And let me take a look. Examples, and it's going to be, yeah, it's a fifth example. It's a fifth example. Let's do cargo run example. Right. So essentially, it enables you with entering some information, and it also supports Unicode, as you can see. It also supports Unicode, and you can even navigate. But unfortunately, there is no any mechanism to remove characters for now. Like you see, it tries to insert whatever it receives as a backspace, which is kind of lame. Something I missed, it was that CI job running examples. It doesn't run example because there's no point in running them on CI. Okay, so our CI, because their result is not verifiable, at least right now. Okay, so what I want to implement, the delete operation for the characters, right? I can move left and right, but I cannot delete or backspace. So it should be pretty straightforward, and after advent of code should be pretty easy and chill problem, hopefully. So let's remove all of that. So we have the latest version, and let's find the edit field. So let's find the edit field. Here is the edit field, and yeah. Doesn't have any ways to delete the characters. Okay, so essentially how we work, we have a widget, right? Was advent of code more interesting than it was? I would admit that it was. I wish I would understand the problem correctly the first try, but I mean, it still was. So the parsing input was a little bit too tedious. I wish the parsing part was just a little bit simplified, because it took like half of a problem. Like why half of a problem is just parsing this stupid format? I don't know. But it was alright. It was alright. I really like how first part of the problem is actually traversing the directed acyclic graph up, and the second one is the same but traversing it down. I really like that, this kind of thing. I was looking for a few minutes. You were generating graph with stuff. Yeah, I was. You can check out my solution here. I already uploaded there. And the graph with generation mechanism is already there. So basically, if you go into the 7th folder and you do make, it will build, run, and also generate dot files that you can then manually convert to PNG yourself. The reason why you have to do that manually is because if you try to convert to PNG the input graph, the actual input graph, it will take like too much fucking time because the graph is so huge. So that's why I don't convert them. But basically, if you run the solution, it automatically generates dot files for you, just in case you want to inspect it. So yeah, it's quite convenient. All right. So what we want to do, we want to be able to delete characters, right? We want to be able to delete characters, and let's introduce the corresponding functions to do so. It's going to be delete, I suppose, back and delete front, right? So it's going to be delete back and delete front. So delete back is for the backspace, and delete front is for just delete. Okay, pub fn delete delete front, and I wonder how exactly we were gonna call them. All right, so let's go to the edit field example. So here's the edit field example, and this is where we map all of this stuff, right? So I suppose we can do the following thing. I wonder if we have key delete. Then here we can delete front. Probably not. Maybe it's something else. Key backspace. So I'm just completely making up these keys because I'm not sure if they will work or not. Delete back. All right. So, and this is, by the way, the example for edit field, right? So essentially you create the edit field, you wrap it with an event handler, and on pressing these keys, you directly call the actions. This is required in case you want to have like different ways of controlling your UI. So you actually control how exactly to interact, how exactly the user will interact with the UI. And for the rest of the event, you actually propagate them forth into the field, and field can handle like the text that the user inputs, right? So just the ASCII characters or UTF-8 characters, it can handle that, but it doesn't know how to handle these things. It has to be handled on a level higher of the UI tree. All right, let's try to compile that. Cargo builds all targets. Now let's see how it's gonna go. Okay, so yeah, so that means this kind of thing does not exist. So delete matched any value. Okay, so if I remember correctly, delete next, delete previous. I mean, it doesn't matter. So the real problem here is that we don't have these keys, and I don't know how they're called. I think delete is called DC. What about backspace? That's very strange. So what if I do something like that? Will it work? Aha! Okay, so I think if I remember correctly, the DC is delete. Yeah. So now we solved the real problem. Okay, let's try to run this thing. And if I try to do backspace, it crashed with to do, not yet implemented. Perfect. And if I try to, press delete, it also crashed with not yet implemented. Okay, so we nailed them down pretty easily. Cool. So let's go to the edit field. And delete back. What we need to do? We basically need to remove the current character. No, not the current character. Current character is the one at which we're looking right now. So that means we have to delete the previous one. Yeah, what we have to do, we have to take the self cursor -1 and delete that character. Yes, that's what we need to do. So we store characters in a vector of chars because we need to support Unicode, right? So let me see, where is this stuff? So let's take a look at the vector. How do you delete? Remove? God damn it. Okay. Removes and returns the element at position index, shifting all elements after it to the left. Panics if index is out of bound. That's very interesting. I think we need this one. Yes. I think we need this one. So we only have to do that if self cursor is greater than 0. Right. So, and then I do self text delete admin like this. There we go. So that should be all right. remove, I'm an idiot, Jesus Christ. I'm already tired, like I spent 2 hours, 2.5 hours solving Advent of Code with graphs and shit in Go, so cut me some slack, okay? So I might be doing some really Pepega shit right now, because I mean, just falling asleep. I really apologize for, you know, for doing Pepega stuff. Just 2.5 hours of graphs and Go is just brutal. Alright, so this is not really gonna work if the text is empty, right? If the text is empty, so we'll see. We'll see. Slack granted. Thank you so much for granting me some slack. Okay, so now look. Oh shit! It does not update the cursor as well. Yeah. So another thing we'll have to do, we'll also have to update the cursor. We might as well actually do something like this, cursor -1, right? And then we can just do it like that. So let's see. So I'm gonna input some text, and I can delete that. So what's funny is that we also can have Russian text, and we can also remove each individual Russian characters, right? So our edit field supports Unicode, right? In the form of UTF-8, right? It can detect UTF-8 sequences, and if it detects like a character in UTF-8 sequence, it adds a single character. This is one of the reasons why we have a vector of chars instead of strings or anything like that. So yeah, no emojis. Well, I think you technically can do that. So you can copy-paste that and then insert it, and that's really strange. Why did it insert char? Wait a second. Okay. What? Okay, so I'm gonna copy-paste it one more time. Oh, there we go. It worked. So it detected an emoji, and you can delete it with a single backspace. I think it worked. I'm works, control plus backspace, selection. We don't have selection yet. Oh, by the way, that's a good idea. Because we only recently started to implement cursor is capped. Yeah, I know. Thank you for mentioning that. I think. Oh, by the way, let me see if I can include that. I think I should be able to do it. Yeah, it works. It's pretty cool. And you can do it like that. So yeah, you can have like a text editor soon. So you'll be able to have a text editor here. It's pretty cool. All right. So to do edit field does not support selections. There we go. How about that? Alrighty. So is it gonna? I already checked that. Doesn't really matter. So I wanted to check the special case. I want to check a special case if we have something like this. Okay. So if everything is empty, it doesn't panic. So that's cool. I like that. Okay. Delete is still not implemented. Delete is still not implemented. Let's quickly implement it. It's kind of strange. Right. Oh, because if the text is empty, you're gonna be forced to be 0 anyway. Yeah, that's why it kind of works. Okay, we can do something like this, so we can have some sort of prevention. And cursor is less. Cursor then is less than self text len, just in case, just to be sure that everything's gonna be okay. Control V works. Clipboard. It works on the level of the terminal. The clipboard stuff works on the level of the terminal. Okay, so delete front. So when I do delete front, what I'm essentially deleting is the current character without modifying the cursor. Okay, that makes sense. But there will be a catch if you're at the end of this thing. No, it doesn't really do that. Huh. We'll see. Okay, so self cursor. Yeah. If So in which case we have nothing to delete. Maybe I'm gonna handle that a little bit later. So it's gonna be self-text, and what I need to remove here is just self-cursor. Technically, that's the whole thing. That's the whole delete front. But it doesn't handle corner cases. When the text is empty or when there is nothing to delete, it doesn't update the cursor or anything like that. One of the things we can do actually, if self cursor, I'm not going to do that, so I'm going to do that a little bit later. Okay, so let's just run it. So we can delete back, and then we can try to delete front, and it works. You see, I press delete, it deletes that, and it seems to be working. So one of the things we have here, this is gonna panic straight up. This is gonna panic straight up, because the cursor can be a little bit bigger than the input text itself, than the input buffer, because you want to be able to append at the end of it, right? So here, cursor is pointing at the next character after the end of the buffer to indicate that you appending to the buffer. So right, deleting from here doesn't make any sense. So that's why we need a special condition here. If self cursor is less than self text length, only then it makes sense to delete, because sometimes it will be equal to the length. Okay, so, and let's see how it's gonna work. Okay, so you can delete it like this, and if I go here, it doesn't delete anything. Okay, so that's cool. I think this is a acceptable behavior. Okay, so if I go to 0, doesn't really produce any weird behavior. Doesn't really produce any weird behavior, so I think that's okay. Because at this particular case, right, if it's 0, yeah, so the cursor, okay, I think this is okay. I think it should make dink, yeah, technically it should, but it doesn't. We can try to make dink, but I don't think, like, I don't like dinks or bells, like in the terminals. I think they're extremely annoying. Try one more time without the text. Delete. I'm deleting right now. This works because cursor is equal 0 and the size of the buffer is equal 0. And this is in that case it will be false, because 0 is not less than 0, they're equal. So this is 0, this is 0, this condition is false, that's why we don't delete anything. Make sense? That's why it works. There we go. Press F4. Can you try with multiple lines? I don't think we support multiple lines. Multiple. Yeah, we don't support multiple lines, and I think I forgot to create an issue for that. So let me. Well, we're gonna. Okay, this is a separate mode. Does not wrap during the rendering. This is a completely different issue. Yeah. Edit field does not support multiple lines. So new line and stuff. So we don't handle them right now. We only recently introduced that widget, right? So we're in the active development of that widget. So we just add one operation at a time, right? Not everything at once. Okay, so we introduced a way to delete characters, which is kind of cool. Let me see what we have here now. Okay, so let me remove that. What else do we need here? So this is that, and then I can do backspace. Oh shit, I cannot backspace here for some reason. Wait a second, what the fuck? I think I should be able to. Yeah. Well, I mean, technically, this condition is kind of lame. You don't really need that anyway. Your if is bad. No you. Got it. Backspace intensifies, yeah. Where is the issue I'm working on? So to delete characters. Shots fired. Yes, exactly. Exactly, 39, and let me try to do that. Introduce ways to introduce methods for deleting chars in edit field. There we go. So I want to actually first do a clippy just to check if I didn't do any, you know, linting fakiwaki. Can anyone follow if possible? I don't know. Probably. Maybe somebody can follow. You mean on Twitch? Do you stream anything interesting? If you stream something interesting about programming, I would definitely follow you. For example, if you're developing in native programming languages, like something like operating system or compilers, or something generally interesting, like problem solving, I would follow you. So do you do anything of this kind of content? So yeah, I'll be really glad to follow you. So Clippy seems to be happy, and you do. Cool. Let's take a look. I cannot look at that. Okay. I will check your profile later. He created a Fortnite. Oh, okay. I see. Okay, did I do FMT? I forgot if I did FMT. I'm sorry, I'm super tired. Alright, so let's actually push that and create the pull request. So I'm gonna show you something cool. I think I forgot to add a couple of to-dos that I wanted to add. So we have selection, multiple lines. Okay, edit field does not have a way to jump forward, backward, one word backward and forward. Sure it does. Okay. Why are you doing the whole desk create pull request to your own repos? Here's the answer. So Yatanasov, this is the answer for you. Why do you make pull requests to your own repos? So I'm kind of surprised that you're asking this question, because you've been around for quite some time, you're subscriber, you're VIP, and you still ask this question. This is really strange. All right. Missed that one. Okay. So, okay. So we definitely need this kind of thing because that's exactly what I use all the time in Vim and Emacs, because it's super useful to, you know, just jump like that. Maybe we also need some sort of like a clipboard support. Some sort of clipboard support. Clipboard support for edit field. Edit field, there we go. So this is the additional work we probably need for edit field, that's for sure. Okay, so, and the way we're gonna do that, so I'm gonna go ahead and create a pull request. Maybe I'm gonna put like that. Someone did the Windows CI and he's on Linux, so it is still interesting. Oh yeah, so it's follow up to the question why I do PR. Yeah, because I don't have Windows and it's quite useful to do things like that. Is Beam a Vim for bisexual? Probably. Do they say that in the description? Okay. 39. So additional work. This is how we're gonna call it. I'm gonna push that. Very interesting stream. Thank you so much. I really appreciate that. Okay, so introduce method for deleting, and here's the interesting thing. So probably not everyone knows this thing. Yeah, So essentially, I usually work on a problem, and then if I notice that something needed to be done, I add this kind of to-dos, right? I add this kind of to-dos. Then I create a pull request, right, to check CI and stuff like that. And I have a special tool called Snitch. So what it does, it scans your entire code base and searches for these to-dos. And then it reports them back to the issue tracker of the corresponding project. So look, I'm gonna do report, and I also want to prepend the body saying that this particular to-do was introduced in the pull request number 44. Okay, look, so it found this to-do, edit field does not support selection. You remember how I added that to-do? I'm gonna say yes, report that as an issue. So here's another one that it found. Report that as an issue. Another one, and it's gonna go and report them to the issue tracker using GitHub API. And on top of that, it's even gonna modify the source code associating these to-dos with the corresponding numbers. And it even creates the commits for these modifications that you can then push back into the repo. Right, and now you have all of these to-dos that you introduced during working on an issue linked to this pull request, and you can start working on them later. So does it work with all languages? It's absolutely language agnostic. You can read more about that in here. So the way it works, it doesn't care about your language. So yeah, as it says, language agnostic tool that collects to-dos in a source code and reports them as issues. So as far as I know, it supports GitHub, GitLab, Gitty. I don't remember if it supports Bitbucket. If it doesn't, we have an issue for that. And I also wanted to add support for SourceHot, because I started to use it recently. So yeah, essentially the way it works, right? You may see like a regular to-do. Looks like this. So what it does, it looks for this keyword to do, then it remembers this prefix before to do, and then it remembers this suffix after to do, right? So, and for example, if you want to have a body, you can put it here and it will become the body of the issue. And the way it knows that it's a body of the issue, it looks at this prefix, and all of the consequent lines with the same prefix are considered part of that to do. So you see, it doesn't care what language is, as long as you follow this rule that you have to maintain this prefix. And that's how it works. So it works in any language. So there's even a documentation in the original repo describing how exactly all of that works. So yeah, it's absolutely language agnostic. Feel free to use it as open source. All right, so we're waiting for the rest of this stuff. And I wish I could solve more problems, but I think Advent of Code completely drained me, so I think I can only manage to do one. Yeah, so at least I did something today on related to this UI framework, because that was the plan anyway. So I guess I'm gonna call it a day, boys and girls. I'm really sorry. Advent of Code was really brutal today. So if I'm going to set the prefix to, I can farm issues and committees. No, the prefix is identified automatically, right? So you cannot set it. But I mean, if you do something like that, if you literally do something like that, hello, right? So it will see that it's an empty prefix, and everything until the end of the file is going to be the body of this issue. So you literally can, this is actually a pretty cool idea. You can have a to-do file, to-do, title, body of the issue, and this is going to be like a valid to-do. So basically this is going to be the title of the issue, and everything in the file is going to be the body. That's actually cool. Wait a second. I didn't realize that. It's completely according to the rules of Snitch, and it will work. Shit. Yeah, for example, it would be useful if you created like an empty folder, and you want to do something inside of that empty folder, but you don't have any files there yet. So you drop a to-do file there, and you just describe what needs to be done in that directory. So that's cool. Didn't think about that. You can even you can even call it something like MD. Like, if you have an editor with Markdown support, you will have a Markdown support, so you will be able to do this kind of stuff, like stuff, and yeah, that's cool. I saw how someone was using GitHub issues as a platform to post articles. I don't. It's kind of a strange usage of GitHub issues. I think something like Gist would fit better for blog posts. So, but I mean, who am I to tell them what to do? So, alright. So that's pretty cool. Alright, boys and girls, that's it for today. That's it for today. Thanks everyone who's watching right now. I really appreciate that. Have a good one, and I see you. Guess when? Guess when I'm gonna see you all? I'm gonna see you all tomorrow. Tomorrow, according to the schedule, we're gonna program in C++, but first part of the stream is going to be dedicated to Advent of Code. We're going to try to solve the 8th day of Advent of Code, after hopefully everyone have solved it. Also, check out our schedule page for more information on different projects we're working on. We're working on all sorts of projects. Check out our Woods channel, where we archive our streams. This stream is going to be available there, but tomorrow we upload them on the next day. And also check out our Discord server for offline discussion with the community. And yeah, while you're waiting for continuation of an epic Advent of Code and C++ development, how about we rate somebody? We haven't rated anyone for quite some time. So do you guys have any suggestions on who should we rate today? Do we have any Rust developers or any Advent of Coders? Any Advent of Coders? Togglebit, we rated Togglebit. Oh, Christian, what is his name? I'm really sorry if I'm butchering his name. Yeah, I wish I could copy paste his name easily, but I'm not sure if I'll be able to. By the way, like you see, I cannot select this name. Can anyone please post his nickname in the chat? Like, please. Thank you so much. Because I could try to copy paste it, but my setup is super slow. This is not what I wanted to type. I wanted to type not close, but rate. This is how slow it is. Like, when I'm streaming, this is how slow Twitch. Okay, come on, you can do that. Okay. Alright, thank you so much, Odin. I really appreciate that. Right, get ready for the raid, boys and girls. Get ready for the raid. And I see you all tomorrow. Love you all. Mwah.